Hey, hey, hey! So today, I thought we'd do a little bit of vectors, bitchin'. And I also thought we'd do a little bit of projectile flight. Bam! I want to start projectile flight first, I think. So, well, I know, I do vectors first. So, again, here's vector, here's a vector. Let's say this is your velocity, bro. But here it's your initial velocity at some angle. Let's call him theta. Part of your velocity is going to be vertical velocity, v sub v, and obviously that's going to be v sub o sine theta. And then, of course, your horizontal velocity is v sub o cosine theta. Now, here's what happens. Every second that you're traveling, you are going to travel this far in this direction. 1 second, 2 second, 3 second, 4 second, 5 second, 6 seconds. When are you going to quit traveling? Well, when you hit the ground. Well, what does that mean? Well, when your velocity, so this is just simply going to be x equals vt, v horizontal. In other words, x equals, and this is how we write v sub o cosine t, or cosine theta, times t. But most of the time, your book writes this v sub o t cosine theta, or vt cosine theta sometimes. Okay? Now, in the y direction, bro, you got this. Y equals negative 4.9 t squared plus v sub o t sine theta, because this is your vertical velocity, plus any initial height. So you will cease being a projectile when this baby hits 0, yes? Groom. That is a quadratic. So it should have 2 zeros. Bro, you're right. So if I hit the golf ball off the ground, it was on the ground at 0, which nobody cares about that. Duh. And it'll be down here somewhere when it hits the ground again. Groom, I hit a golf ball, but I hit it off the roof. That's hot. There's only 1 0. Wrong. There's also a negative 0. But again, we only care about this one, right? That's the one we care about. And so when we solve these, we always set this baby equal to 0, solve first, get time equals 5 or whatever. Sweet. Drop it into there. Bam. That's how far she went. It's that easy, my man. So let's do a few. So what you got to tell me. So I hit the golf ball, off of 30-meter roof. 100 meters per second. Dude, you crushed it. 30-degree angle. That's hot. Blah, 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 blah. How far does it go? How far does it go? I don't know. Let's find out. So, x equals vt. So that's x equals v 100 t cosine 30. And then you get y equal negative 4.9 t squared plus vt, or 100t, sorry. My bad. Don't get all mad. 100t sine 30 plus 30. Nice. Now, if I do this, cosine of 30 is about 0.86 times this is going to be x equals like 86t. In other words, or thereabouts. That's how fast we are moving in the x direction. Every second, we will have traveled 86 meters downfield. Yes? Now, y equals negative 4.9 t squared plus sine is a half, so 50t plus 30. So I'm going to set this baby equal to 0. Bam, equals 0. So I'm just going to grab the old Desmos.com because, well, I can. And we're going to graph that puppy. So, Desmos, where art thou? So Mr. Groom is simply going to type in negative 4.9 x squared, negative 4.9. There you go. Plus, damn it, plus 50x plus 30. Whoa, Groom. Dude, that sucker went high. Bro, it did. Notice it hit the top at 5.1 seconds after we launched. That's a fact, Jack. Okay? Notice it went 158 meters in the air, roughly. True dat, homie. Now, the question was, when does it hit the ground? Well, it hits the ground 0.56 seconds before I hit it, which doesn't make any sense, obviously, and 10.7. Now, I'm just a little country boy here. So 10.77, oops, plus 5.68 or thereabouts, 5.68. In other words, the distance from 10.77 to negative 5.68 is 16.45. 16.45 divided by 2, 16.45 divided by 2 is 8.22. That's correct. And then if I take, when I say, 8.22, so 10.77 minus 8.22. Oh, I didn't say 8. Did I say 8.22? Well, let's try it again, Jay. Let's try it again, stupid. Maybe you can do it this time. All right. So 10.77 plus 0.65 is 11. That makes more sense. I know what happened. I don't think I got my dot in there somewhere. 5.71. And if I take 10.77 minus 5.71, I get 5.06-ish. In other words, when was it at the top? 5.06-ish. Obviously, I rounded a skosh. Ta-da, but whatever it is. By the by, a guy could also do this. This is the quadratic formula, yes? So the opposite of b over 2a is the x-coordinate of the vertex, right? So negative 50 divided by 9.8. So negative 50 divided by negative 9.8 is 5.1. Oh, shut up. No, I won't shut up. So clearly from the graph, 5.1 is the max. 157. If I want to know how high it went, I would literally plug that into this guy, wouldn't I? If you put 5.1 into here and here, what do you get? Well, obviously you don't get that. You get 177 or whatever I said, yes? Is it 177? Oh, 157. My bad. 157. And of course, you see that because that's literally the graph you're looking at. Okay? But then the question is, when does it hit the ground? Well, it hits the ground in 10.77 seconds. It hits the ground. Right? But how far does it go? I don't know, 86.6 or whatever times 10.77. And you will get 86.6 times 10.77. And well, that's 866, you moron. It goes 932 meters. Whoa! Well, yeah, you crushed the golf ball, bud. You crushed it. Well, I saw on TV that Tiger Woods hits 100. That's right, miles an hour, bro. Miles an hour, which is like, what, 41 meters a second or something? So, yeah, you hit it a lot further than he did. And you hit it off a roof. We don't tee off from a 30-meter building, typically. Okay. What if you were flying along in an airplane? Wee, wee. And then you just, I don't know, dropped a care package out. There goes the care package. Wee. You were flying along at, I don't know, let's do 200 kilometers per hour. Okay, nice. In level flight, wee. 500 meters off the ground, because I guess, why not? Where will it land? Well, it's going to do this number, isn't it? Ooh. And the thing to remember is it is flying in level flight initially. It's always going to have the same initial velocity, correct? Notice I have the same initial velocity of 200 all the way across. That is, it was basically just falling because the angle here is zero, S0. And what happens is in the first second, you barely fall. You with me? The second part here, you fall a little more, and then a little bit more, and then a lot more, and then a lot more, and then so on. And then lo and behold, when you trace it out, what do you get? You get yourself a parabola. Oh, that's the idea. So x equals VT cosine theta. Last I checked, the cosine of 0 is simply 1. And then y equals negative 4.9 t squared plus VT sine theta plus h sub O initial height. The sine of 0 is 0, so that part goes away. So when does it hit the ground? Bro, I don't know, but I do know that this would tell me the answer. right? Divide, so 5 honey divided by 4.9, square root is t. 500 divided by 4.9. What in the Sam Hill? 500 divided by 4.9. Square root of that is that. About 10 seconds to hit the ground, right? 10.1 seconds. How far does it fly? Well, literally, it is what you think it is, except this needs to be in meters, yes? So meters per second. So that's 200,000 divided by 3,600. Oops. You hippie. And so you get 55 meters a second times 10.1. So it's going to fly times 10.1. Oh, you pig. It's going to fly 561 meters downfield before it hits the ground. Make sense? Awesome. Mr. Grimm, let's launch Addie out of a cannon. Atta girl. She's in here. Got her goggles on. Oh, she's ready to go. Let's go. Boom. Okay, there she goes, flying. There she goes, flying through the air in the greatest of ease. She's the daring young gal on the flying trapeze. Nice. So from here is 20 meters to 30-meter bag. This is a nice bag that you can land in. It's awesome. It's about 5 meters off the ground. Okay. Yeah. And so we would like to launch her such that she lands in there somewhere. Okay. And yeah, anything, if you launch her too fast or too flat of an angle or too steep of an angle, we're going to miss. For instance, if you get her legs, boop, sorry. Or the one where, whoa, it's off the page. And we're back. That's not great. Or this classic one, Mr. Groom, we just launched her and we just, whoops. So we need to figure this out. So x equals vt cosine theta. Y equals negative 4.9 t squared plus t sine theta plus h sub o. So her launch is, I guess, 7 meters off the ground, sure. And that's where she came out the tube there. And so the question is simple. Oh, we're going to launch her at a 40-degree angle. Okay. So the question is, how hard do we have to launch her to land where we want her to land? Yes. And so let's start filling in the pieces. So she needs to go somewhere between 20 and 30 meters. Yes. And so I will do, well, actually I'm going to do, well, I'm going to do them both. So 20 equals VT cosine 40. You with me? And then 5 equals negative 4.9 t squared plus VT sine 40 plus 7. Now you do that, you're like, oh, interesting. Now I have two equations with two unknowns. That's a fact, Jack. Let me show you something pretty cool about this. If I solve the top one for t, what I end up with is 20 over v cos 40. You with me? And so if I do this, I get, well, wait a minute. You know what I should do is I should just make this x. And I should just make this theta for a minute, huh? Oh, yeah. And so if I do this, what I'm going to do is I'm going to plug it in there and there. And so I'm going to get y equals negative 4.9 t squared plus v t sine theta, right, times t. Oh, that was t, stupid. That was t, you moron. Plus h sub o. You see this? So when I do this, now what do I have? Well, this is interesting because watch this. We cancel that out, yeah? And now, if you look at it, oh, wait a minute. This is tangent. Oh, baby. So now I get y equals negative 4.9. Now wait for it. X squared over v squared cosine theta, or in other words, secant theta, because it's on the bottom, right? Squared. Plus x tan theta plus h sub o. Notice that we are solving for this cat. Are you with me? How hard I got to launch him? That's the thing. That's what we're looking for, right? That's what we are solving for. So if a guy's playing along at him, you can see it's not this hard to solve for this guy. We'll actually do it with the problem I just gave you, but kind of keep that in the back of your head as we go along. So y equals negative 4.9, and then x squared is, I'm going to do 20 first just for fun, over v squared. Oh, wait, this is 5 over here, right? Boom. Cosine of 40 squared plus x 20 tangent 40 plus 7. Okay, so if I'm doing this, I'm just going to go 5. Oops, I'm in radians. I got to get that back to degrees. One moment, please. Okay, there we go. So 5 minus 20 tangent 40 minus 7 is, well, I don't know what it is, but it's a mess. Negative 18. You with me? So I got negative 18.78 equal negative 4.9 times 400, just for fun, over v squared cosine of 40 squared. Okay, now I'm going to go ahead and punch some of this out. So negative 4.9 times 400 divided by cosine 40 squared is negative 3 whatever. So negative 18.78 equals negative, what did I say? 3340 over v squared. So if you play little musical chairs, you get v squared equals 3340 over 18.78. Damn it. And you get 177. V squared equals 177. Square root that. And you get about 13 meters a second. Okay? Now, the only thing that really changes here, right, is that I would change that to a 30, right? And I would change that to a 30. Okay, so that would make this 900. And I just redo that first calculation again. So, so back up here a ways, that one. So I get, oh darn it, now I get negative 27 point whatever. Oh, fiddle faddle. Fiddle faddle, I say. And then, there we go. So negative 7515 over v squared. And so again, if you take 7515, clear, grab him, divide by, grab him, you get that. So 276 equals v squared. And if you square root that to the 0.5, you get 16.6. As long as we keep your initial velocity between those two things, you're going to land in the pad, yes? Anything more than 16 point whatever, you are out of luck. Yeah. So just be aware of that. We need to get you launched in there. We can do it a couple different ways. We can solve for any of those missing things. We did solve for initial velocity. We could have solved for initial angle just as easily. I know what you're thinking. Groom, can you do a different one? Can you? Can you? Can you do one when you can see how far it goes or this or the other? Landon Schaefer. Big sexy. Oh goodness. All right. Anyway, so where was I going with this? Yeah. So right. So let's launch something, shall we? And let's launch it from the ground to the ground because I feel like it. Okay. And let's say they went 100 meters. That's hot. Okay. And let's further say we launched it at a 10 degree angle, rather. That's cool. And, well, how fast did it go? How fast was it going? Yeah, I don't know. I feel like we can figure that out, though, right? So you can do that easy enough. So 100 equals VT, right? Because the cosine of 10. And then 0 equals negative 4.9 t squared plus VT sine theta plus 0. So just nada on the end of that pig. Boom. How do I solve it? Hey, same way as last time, but always solve for t on these guys because if you don't, you'll screw things up, right? So if you're going to try to, because if you have to try to solve for v into here, right? Yeah, it's a whole mess. I promise you. Yeah. Yeah. Anyway, so you could solve for t, okay, like I did there, or I'm sorry, what am I trying to say? You could solve for t, which obviously I did, or you could solve for v if you want to. Let's see what happens with v this time, just for fun. 100 over t cos theta, which cos 10, of course. That's 100 divided by cos of 10. Oh, I don't think that's right. So let's verify this is in degrees or not, or radians or not. So if I do cosine 45, that is correct. It is in degrees. So 100 divided by cosine of 10 is like 101.5. Okay, how exciting. So this is 101.5 divided by t. You with me? So if I do it this way, I'm going to get negative 4.9 t squared plus 101.5 over t times t sine of 10. So, stop it, times the sine of 10. 17.63. So if you do this, you're going to get 0 equals negative 4.9 t squared plus 17.63. That's it. And then if you do this, you set it equal to 0, you get 17.63 over 4.9 square rooticated. So divide by 4.9. What the heck, bro? Stop it. Bro! 17. And take the square root of 39.5, and you get something like 6.2. What the hell's going on? Okay, we're going to try it again. Mr. Groom can't run a calculator because he's a moron, apparently. What a moron. 17.63 divided by 4.9. Oh, it's 1.89. Duh. All right, so it takes 1.89 seconds to get. That's not what I asked for. I said, how fast are we traveling? Well, I got to be honest with you, friends. If it takes less than 2 seconds to go 101.5 meters, you, sir, are hauling buttocks. So if you plug this back into here, you get 43.7 rather meters per second is how fast you'll be traveling. That's kind of thing we'll be working on, and it's pretty easy to do. Okay. That is projectile flight. Again, if you're adding vectors, I do want a few little vector additions in this chapter. Hey, this vector here, let's say he's A, he's 5. And you got this guy here who is B, and let's say he is 7, and this is a 30-degree angle, and you've got this cat here, negative 45 degrees, whatever, but it's 11. How exciting. This is C. And so if you do this, you go, I don't know, 2A plus B plus C. If I did that, well, 2A is now 10 in this direction, yes? Okay. And then here, plus B, so you're going to have B goes up like this with a 7, like so, yes? And then from there, this again is your 30 degrees. And then here is your horizontal again, and then you get your negative 45 and down 11. And crooked as a dog's hind leg. And look where you landed. You're probably going to be a little bit negative here, yes? But you're mostly this direction and just a skosh negative, most likely. But let's do the math, shall we? So from hither to thither is 7 cosine theta. 30 rather. And this is 7 sine 30. Boop, boop. So this one is going to be, because that's 45, it's 11 cosine 45 and 11 sine 45. Of course, that's going to be negative because we're going downhill. I love talking weird sometimes. Groom, all the time? Sure, why not? 7 cosine 30, 6.06. This one is 3.5. I know that off the top of my head. 11 cosine 45 is 7.78, and then negative 7.78. That's hot. Let's do some plussing and minusing, shall we? So what did we do here? We went to this direction. We went 10, and then we went 6.06, and then we went 7.78. Up, we went 3.5. Down, we went negative 7.78. There we go. For a grand total of, let's add them up. 10 plus 6 point, dang it, plus 7.78. 23.84. And then you're going to have 7.78 minus 3.5 is 4.28. For a grand total of 4.28 square plus 23.84 square, and then the square root of 586 is 24.2. Nice, that's hot. How do I find an angle? Arctan 4.28 over 23.84, right? Or you can do other things too. I just typically I do arctangent, but you obviously could do arcsine or cosine since you know everybody here. 4.28 divided by 23.84. So 10.177 degrees. Yay, and the crowd goes wild. Okay, are we gooch with that? I hope so. I hope so. All right, let me know if you need any help, and goodbye.